Hi, boys and girls. Welcome to lesson 2, rotating tape diagrams vertically. We are going to see how we can collect data and use data in a tape diagram and just do a magical rotation. Watch the video. There's horizontal. There's vertical. How can we use tape diagrams to help us display data? So let's start with a little warm up here, boys and girls. We have group counting on a vertical number line, and I noticed that there are numbers. I see 16, 32, 48, 64, and 80. But I also notice that there are tick marks equally spaced between each of the numbers, which means that there's a smaller skip count in there. So I'm going to look at 0 and 16. And I'm going to ask myself, what is halfway? I notice, and I think, 8 is halfway. That means that the skip counts are 8. I'd love for you to go back to yesterday's video, lesson 1, and I'd love for you to practice that fluency again with your skip counts of 6s, 7s, 8s, and 9s, even if you have to use the multiplication table that I provide for you. Because it's very important that 3rd graders know all of their multiplication facts by the end of 3rd grade. So boys and girls, let's dive deeper into reading tape diagrams. I have here a tape diagram. A is 4 groups of 8 and B is 7 groups of 8. They are equal values within each of the units, groups of 8. So what is a multiplication equation that represents each of the tape diagrams? 4 groups of 8 is 4 times 8. 7 groups of 8 is 7 times 8. So 4 groups of 8, 4 times 8 is 32, and 7 times 8 is 56. When we look at tape diagrams, we can compare and contrast them. So how many more groups of 8 are in B than A? Focus here where I'm circling. There are 3 more groups of 8. So that means that B has 3 more groups of 8, or 24 more, let's say apple, than B. If I want to know how many are in all, I can add 32 plus 56, or I can figure out how many are in 11 groups of 8 and multiply. It's going to give me the same answer. So 11 times 8 is 88, and 32 plus 56 is 88. So there are a total of 88 apples. And I just chose apples for fun. Let's move on. We have a word problem here. And it is our practice problem for today. So you're going to need to have your paper and pencil ready to go because it's important that you practice this along with me. Risha played in 3 basketball games. She scored 12 points in game 1, 8 points in game 2, and 16 points in game 3. Each basket that she made was worth 2 points. She uses tape diagrams with a unit size of 2 to represent the points she scored in each game. How many total units of 2 does it take to represent the points she scored in all 3 games? So I need to use all of this data. So I'm going to start with game 1, game 2, and game 3, because it's important that when you have data, you label it properly. So I need to show a tape diagram with 12 points in groups of 2. So 2, 4, 6, 8, 10, 12. That means I need to make 6 groups of 2. And that is 12. I like to put the total on the end. Let me fix that here. Try to write bigger. And then I need 4 groups of 2. It might be easier for you to do the count bys first and then build the tape diagram around that, which is 4, and then 2, 4, 6, 8, 10, 12, 14, 16, And now I need to find the total for all 3 games. You might be someone who likes to skip count up, and you might be someone who likes to add the values. I'm a value adder because I do old school math. And I got a total of 32 points. So Risha scores a total of 32 points. Before we move on, let's look at the data here and see if we can compare and contrast some numbers. So which game has the most points? Game 1, Game 2, or Game 3? Game 3 has the most points. Which game has the least? Game 2 has the least points. Which game is double another game? Double means if you have 6 in game 1, you would need to have 6 plus 6 for game 2 or 3. Double, double, double. Look at game 2 and look at game 3. Game 3 is double the amount of game 2. 4 plus 4. Pretty cool. That's really good math thinking if you were able to figure that out. So we figured out the total and we compared some of the total points per game. Let's see what happens now when we go to rotate that tape diagram vertically. Does anything happen? So here's game 1. There's game 2 and game 3. We can see the data, we can see the values really nicely done. When we go to rotate it, does anything change? Besides the fact that the numbers are looking a little funny and in a different direction, none of the values in game 1, game 2, or game 3 change. Very interesting. It looks like another kind of graph. Doesn't it look like a bar graph? We're going to wrap up with a question. How is a regular tape diagram like a picture graph? On the left, we see the tape diagram we just created. And on the right, we see a picture graph. A picture graph uses a picture to represent a certain amount of data. In this case, the picture is a cup with a straw, and each cup represents 100 drinks from the restaurants listed below. Tasty Taco, Corner Burger, Paul's Pizza, Chicken Hut, not Pizza Hut, and Pasta Dreams. I think I'd like to go to every single one of those restaurants right now. So is a tape diagram like a picture graph? Why or why not? I hope you have a great day of learning today, and I can't wait to see the work you're doing on